Hello everyone, welcome to my channel. So in this video, we will continue our topic about probability distribution. So in last video, we already talked about what is a probability distribution and how we can compute a probability mass function. So for probability mass function, we generally denote this by PMF. And for probability distribution, the probability mass function is a way to describe the probability distribution. However, there is another way to describe the probability distribution. The method is we can define a cumulative distribution function. So we generally denote this by CDF. So let me write down the definition of this cumulative distribution function here. So for a given discrete random variable denoted by capital X with a finite possible value x1, x2 until xn, then a cumulative distribution function is also a function with some requirement. So here actually for this one, they also have the function should become value larger or equal to 0, and also this function should have smaller or equal to 1. So this is one requirement. And then the second requirement is here, if we have the value x is smaller than y, then we should have this function actually is a non-decreasing function. So in other words, the value of this function at x should also smaller or equal to the value of this function at y. Okay, and then the third requirement actually is similar to the definition of our probability mass function. This is exactly how we can compute the cumulative distribution function. So this is our function x. Fx is the probability of our random variables value is smaller or equal to our small x. Or in other words, this is the sum of our PMF, probability mass function, when our small xi is smaller than the requirement x. Okay, so this is how we can compute our cumulative distribution function. Okay, so this similar to the previous definition of PMF, probability mass function. The first two requirement is straightforward from our axiom of probability. So non-negative and non-decreasing. And the last one is how we can compute our CDF. So now let's look at one example. So I will use exactly same example of our previous PMF, probability mass function. So here we still look at a coin game. We flip 5 coins and we will stop immediately when we get a head. So in this question, we didn't set a random variable related to the head, but we set the random variable x be the number of tail we will get in this game. So in last lecture, we already explained how we can get the possible values of our random variable x and how we can get or compute the probability mass function with check they are correct or not. So here the answer is the part I circled by this rectangle. So if you're interested in how we can get this equation, please look at the previous video about a probability mass function. So now when we already have this probability mass function, the next thing we want to compute is we want to compute the cumulative distribution function. So to compute this one, what we need to do is we need to compute the function fx. So now this x will have several values. So the first one is x equal 0. So this is our first possible value of our random variable. And we can have x equal 1. So we use this possible value to as our distributed point. So that means if you look at a line, so here, for example, we think this is our x-axis, right? So then we start with 0, 1, 2, 3, 4, and 5. This is 6 possible values of our random variable x. So then this will distribute it or divided our line to 6 parts. So this is smaller than 0, and between 0, 1, between 1, 2, 2, 3, 3, 4, 4, 5, and larger than 5. So then by this way, what we will do is we will use this possible value to divide it our line here. So what we do is x smaller than 0, x greater or equal to 0, smaller than 1, x greater or equal to 1, smaller than 2, and we will do this for all of the other points. So now we have all of these possible intervals. And then what we will have is, we know this is our value of small x. So by the definition of our fx, what we have, the fx is the sum of xi smaller than x, and compute the probability of capital X equal small xi. This is our definition, right? This is our definition of CDF. So then we should do same for all of this interval. And then by this different value of our x, what we will have? We will have the xi smaller than 0. We don't have any possible value of our random variable is smaller than 0. So that means in this situation, what we will have, this is 0. We have nothing of xi smaller than 0. And then when the x is larger than 0, smaller than 1, is there any xi is satisfies this one? So yes, we have 1. This is 0. So that means here what we have is this is a probability capital X equals 0. Okay, and then we will do this for the x between 1 larger or greater or equal to 1 and smaller than 2. So in this situation, we have two cases. So we have small xi equals 0, and we have the small xi equal 1. So that's why here we have this is some probability of random variable equals 0 and probability of random variable equal 1. And we will do this for the all other interval. And for each of them, we will have one more term we need to add here. X equal 2. Okay, and we will do all of them until x is larger than 5. So now what we do is we will sum from 0 to 5. So that means this is x equals 0 plus x equal 1 plus the probability of x equal 5. Okay, so this is how we can compute this. And then the next thing is, now after we get this equation, the next thing is we just need to plug in what we have, the probability for here. So here in this value in the right rectangle, we need to plug in all of the number here. So that means for the first one, 0. And then we have, maybe I can use next page. So for the first one is 0 for x smaller than 0, 1/2 x between 0 and smaller than 1, 1/2 plus 1/2 square. Okay, and we will do this for all of the values until x larger than 5. So this is 1/2 plus until 1/2 to 5. Don't forget this one is plus 1/2 to 5. Okay, so now what we will have is, if you use your calculator to compute this, you will find this is start from 0 and then it's 1.5 for the second one, 0.5 for the second one, and then until the last one is equal 1. This is x greater than 5. So actually for our cumulative distribution function, it's always start from 0 and is always in at 1 as a step function. So here, if we write down what is a picture of this function, you can find this picture of the function is start from 0. So let me write this by a color. So this is from 0, 1, 2, 3, 4, 5. And for this value, it will start from 0 here. And let me write this more clear. 0 here, and then it will jump to 0.5. Okay, so I write 0.5 is here. This is 1, this is 0.5, this is 0.75. Okay, so the second one is here, and the third one will become here, and the next one is this, and this okay, let me write this more clear here. Until the last one should become 1. And so here we know the value of this function when x equals 0, it should be equal 0.5, right? So how we can show this? So we will use a circle when this value is equal 1 and use a dot here to mean when our function x equal 0, then the value of this function should equal 0.5. So this is a way how we can, when there is a jump, we will tell the reader how to find the correct value. So we will do all of this, and you will find they always have a dot on the left inside and a circle on the right. So this is also a very important character of a graph of a cumulative distribution function. Okay, so this is my example of this lecture. So here we will have a little more about this CDF. So this is about the relationship between the CDF and a PMF. So the first relationship between the CDF and the PMF is you can find here, because the definition of CDF is a sum of some value of our PMF, right? So actually the jump of at each x of our CDF is equal to the PMF at this point. So if I write down this is, so this is the meaning of this relationship. And then this is actually we compute the CDF when we have a PMF, right? However, if we only have the information of our CDF, how we can compute the PMF? So this is what we can do by the jump. So if you assume here generally we denoted the CDF by a capital F and we denoted the PMF by a small f function. So if we given any CDF function capital F, we can use this limit to help us compute the PMF at a value. So here in this symbol, this limit, it means this is a left limit. So it means we will approximate our function from the left. Okay, so this is a left limit. So if you are not familiar about the left limited, maybe you should review some materials in your calculus. So this is how we can compute the PMF. And actually, we can also use similar way to compute the probability of our random variable between two values. So if we want to know the probability of this random variable between greater or equal to 0, A and smaller or equal to B, then what we can do is we can use the value of our CDF at B minus the left limited of our CDF to A. Okay, so this is a way to compute how we can get a PMF when we have a CDF, and how we can compute the probability of random variable between an interval when also we have a CDF. So this is my explanation of the CDF cumulative distribution functions in this video. And in next video, I will talk about two important terminology of our discrete random variable, mean and variance. So hopefully you will look at my next videos, and please subscribe this channel.